Hey there, Alex. Thanks for joining us here on the Making Math Moments That Matter podcast. I'm looking forward to digging in with you. So let us know a little bit about where you're coming from here today and what's going on in math in your neck of the woods.
So I have been working on research and been out having a look at what that looks like in the classroom. The elementary classroom, so grade 3, 4 is where we have been for the last few years. And now I've been out with the teachers to look at whether or not this is going to work in their classroom. So that's been about since the pandemic. It was supposed to start in the pandemic, and indeed it did. We've got interviews with kids with masks on, but things slowed down a little bit at that point.
Sure. Awesome. Let's talk about your math moment. You know, when we say math class, there's always this image that sticks in our minds and, we carry with us all these years. And so when I say, Alex, when I say math class, describe like what is sitting in your mind's eye right now about math class, and like what is that memory that, you're carrying with you all these years?
Well, it's actually not. I mean, I have a bunch in math class, especially when I got into teaching. But the first math moment I remember was in our kitchen at home when I was a kid. And my brother is about 5 years my senior, and he brought home the new textbook. And the new textbook was the one that was introduced after Sputnik was put up, and the Americans were worried about losing the space race, etc. So it was about set theory. And I can clearly remember my father and my brother looking at each other and my brother saying, Dad, I have no idea what this is. And Gord looking at it and Gord going, I have no idea what it is. You're going to have to talk to your teacher. And so, it was interesting to me because until that moment, my dad's math was, I always thought, very strong. And I think it was, but I think that the theory behind it just made no sense to him. And it didn't mean a lot to me at that point. But later, when I think back about it as a researcher, I understand, sometimes we're shooting for things that might not be that useful to teachers in the classroom and might have actually a negative impact, which is certainly the experience of some kids at that point. And my brother, he said that was it for math for me.
Right. Yeah. And he was like, that's it. That's it. There's no more learning. I've tuned math out.
No, he tuned math out. He became a historian and a lawyer, but math was no. He did not like math after that. That's his memory.
And was that like the opposite for you going into math as a major field of study?
It wasn't a major field of study. My early math, the school math was straightforward. I found it easy, but I didn't love it. I liked math outside of school. I liked all the things. I liked the card games. I liked learning how to bet on the ponies. Whatever I was doing, the math outside of school was fabulous, but the math inside of school was uninteresting.
It's like two separate worlds, right?
Two separate worlds, totally.
Yeah.
And it was only because my students struggled, some of them, and I wasn't very good at helping them, that I realized I'm actually pretty interested in this and how to do a better job of it.
Right. All right, let's get into talk about multiplication. I think because it's been a major focus of some of the work that you've been working on. Now, I guess here's the question: is that does the world need more multiplication professional development? is why we because you think about it, right? Like it's been the major focus of say math. When you say math, when someone says math, they're probably like, I'll be honest. We've asked, this is episode 400 and something of the Making Math Moments That Matter podcast. And every guest over those years, we ask about their math moment. And I would say at least 300 of them are about multiplication.
Yeah.
And whether it's always related to like math facts or around the world or mad minutes around multiplication. And so it's like, when you think about it, it's like typically the multiplication is probably the most studied, basic operation in mathematics. And do we need some more help here? And so I guess why focus on this?
Okay, that's That's a great question. So why bother?
Yeah, exactly.
And so originally, I didn't actually want to do more on, how to teach it. I just wanted to map out how do kids develop over time in a math class in multiplication and division. All I really wanted to do was to duplicate what I had done with my first book, which is just looking at kids' videos to understand their thinking, like what is going on when they give a certain answer, um, in order to help teachers look at the strategies that kids are using and make sense of them, because some of them are more difficult than others, especially if you as a teacher don't think about things that way. But they also give us a huge amount of information. So like with addition and subtraction, we had looked at what do kids do with 6 plus 8. And when we look at that, or 8 plus 6, when we look at that, some kids have to count 3 times. They've got to count 8, they've got to count 6, they've got to count from 1 again. And the teachers are kind of weeping at this point. But that's what they need to do. Whereas other kids, they know that they can decompose the number 6 and use that 2, that'll get them to 10 and over. And that's a much more sophisticated strategy. So in my first work, I was just looking at that. What's that pathway? What does it look like? And where does it go? In order for teachers to assess their kids and think about what's next. And that's what I was going to do. It had nothing to do with instruction. And it was only when we started to read up in instruction that I came to the realization that maybe the way I have always taught it, and that's why I was interested in your background, John, because this might be new material for you, but the way I had always introduced it was groups of, so 3 groups of 4.
Right.
3 groups, put 4 in each. But it turns out that is, I think, actually not the best way to go for good instruction in terms of building a foundation for kids. So in terms of your question, I would have said, no, I don't think we need any new material. We got a lot of great material out there. I've used it. And it was only through research that I began to doubt the wisdom of that idea and realize that maybe there's a better way to go about it than what we do in North America. And I have to say that's in North America.
Right. So I think we're all listening, like we're all curious right now, because when you're saying we all would normally teach this as a thing about groups of, and you're saying, let's rethink that. Tell me more.
So what we realized, which you will know, but is not how we thought about it at the elementary level, is that in any word problem, my kids might learn that even if they learn their facts, they might struggle to learn their facts, but if they learn them, lots of them struggle with word problems. And that was the issue. We wanted a foundation that would set them up to eventually know things automatically, but be able to use them in a word problem or real life. Because what is the point of learning all that material if you can't apply it? So when we looked at word problems, we realized, well, in any word problem, at least at the elementary, we're dealing in quantities. So quantities meaning number plus a reference. So it refers to something. So when I think of 3 groups of 4, I'm just thinking of something as if there were no referent. But if I ask you the problem, I have 3 packages of gum. There are 4 pieces per pack. How many pieces are there? The reference in that pieces per pack, and packages, they're all different. And so we realized that actually we have to pay attention to that and to start with that, what's called the intensive quantity, or you would think of it, I'm sure, as rate. Like, what is that rate iterated? And once you do that, then all of a sudden, as an elementary teacher, I also realized, well, that is different than addition. And this is why addition isn't really kids can add to multiply, but it's not the foundation for multiplication. It's a different thing. When you're dealing with word problems that are around addition, if you had 3 and 4, you're dealing with 3 pieces, and 4 pieces is 7 pieces. The referents are all the same.
Right.
Whereas if you pay attention to them in multiplication and you're really setting up for multiplicative reasoning, then I think you start with rate, or you start with that intensive quantity iterated. And that's a different way than the way I would have taught it, which was definitely 3 groups, 4 in each group, as if it didn't have a referent.
Right. Because I like the fact that you're saying we need to build rate in from the start, because it's so fundamental, and because my head immediately jumped to division. When you were thinking of that, it's like when we're saying like if you use the words of like per, and you're saying like there's a rate involved here in any multiplication, and then when you go to do the division, it's like now I have like part of division, quota division is now easily to think about. Like it makes a lot of sense to come at it from that way. And I guess like are you saying like too that if it's not just the subtle change of including the rate, because a teacher might say, well, can I say there's like 3 groups, but there's 4 per group? Is that, you're saying it's not enough? Like we need more context to the when we introduce, or is it about the rate more?
Okay, so that's a great question and a hard question. I think it is still different than just we have built what we see again as the continuum of development. And we have kids who they're drawing those 3 groups and thinking about it as 4 per group. But it seems subtle, but it is different to think about creating that intensive quantity and then iterating it, because it is those 2 things together. It's our relationship, which is pieces per pack. It's the relationship between the other 2, and it is the development of that relationship and really understanding that I think sets you up for multiplication. Exactly the way you talked about division, like the setup was, we could talk about it more, but it was a smooth setup once you had that in place. And it's not that the 3 groups of 4 kids will figure, if we had done that as a control, we would have had the same number of kids being equally able to solve that problem. It's that later setup that I think is what it does for kids. And the question would be, well, maybe it does that for kids, but maybe it's too difficult to do. But we did not find that. We found, we found actually the opposite. We realized that kids, when I went back to look at the old video of grade 1, 2 kids, because I asked them the same problem. So I was really lucky. I asked them the same problem. I switched up the numbers, and I made a kind of classic research error where I actually commuted the numbers by accident. And so I had all of those situations, and it didn't matter what the problem was. The kids always start with that intensive quantity. Before they learn multiplication the way that we teach it, they start with that. They think, okay, well, that's 4 per pack, and they pull out 4. We have pictures of kids doing it. Either they're concrete modeling or they just start counting on their fingers or whatever, but they start with that 4, not with 3 and then, 4 in each.
Right. So what does that look like long-term retention wise for kids if we're going to teach multiplication and we're going to introduce it with the idea of rate from the get-go? You're saying students are picking up on that already anyway when we're introducing it, because you think, rates, that's for later grades. We shouldn't be introducing that early on. You're saying the opposite is true with the evidence that you've seen. How does that just naturally just keep going? Like, is it naturally like it's just get stronger over time?
So we're just right now looking at 5, 6. And so far, yes. Like it is smooth. And I mean, they get introduced to typical rate in grade 5, 6 anyway. So they already have to be there, and they're already dealing with other situations where the groups of just falls apart for them. Anything that has like a continuous referent, that has measurement, and later things like kilometers per hour, whatever it is, those groups of, if that falls apart for them, it falls short. So to my mind, this is a much bigger foundation, more representative of what they're going to have to do. And so far, yes, it's looking good. We're just in the middle of devising the next round of lessons into 5, 6.
So why do you think then, if it's like, it's naturally, we already start with it when you were saying when kids already build upon it anyway. Is like, why do you think we educators, like what you
Did
were saying,
that.
you would have taught it as just groups of and drawn pictures? Like you're drawing the rate anyway, but I mean, like why exclude rate from the get go way back then?
I think, like, I tried to find this research. I looked everywhere, in terms of finding out, well, whose idea was this? Because I know in other countries is not how they necessarily teach it. So I thought, well, somebody's come up with this idea. I could not find the source of it. So it's conjecture on my part, but I just
Hmm.
think that kids, for whatever reason, teachers, well-meaning, or people like me, well-meaning, who knows? I thought it'd be easier not to have to think about those other things and
Right.
just to treat it as if there were no reference out there. That
Yeah.
just let's just draw it, and this is the simplest drawing we can do.
Yeah. That makes sense. Like, because I think we have a history of we used to call them naked problems. Like you got to front load the material. You got to help kids just get the basics, and I'm using air quotes here, like which is like no context, because context actually makes it harder, which we all know is not true.
No.
But we this is like it's almost 101. If that ever existed, it's like for some reason when you learn how to teach math, you were like, don't include word problems until later. Let's just do it abstract or before, and I guess that's where this would come from, right? Because it's like you're stripping the context, therefore you're stripping the idea of a rate out and saying like we're just going to do groups of and draw pictures.
Yeah, and it is. I think that that's a really good comparison. And really, it's where I got interested in things because Tom Carpenter, I don't know if you're familiar with his work, but he basically said if you ask a good problem, this will help kids. It's actually easier for them if you give
Right.
them a context.
For
And he was
sure.
totally right.
Right. Yeah. So let's talk about teachers' moves. Like what as a teacher I'm listening, or also a lot of leaders, coaches, coordinators are listening to this podcast. So we're helping teachers kind of make this transition. There's probably lots of standards that don't include this right now, at that, say, grade levels that aren't including rate. How do we help make the transition?
I'm breathing heavily here because it's why we ended up doing some lessons. There
Hmm.
wasn't a lot of material on it. And I don't, you know, it wasn't what I wanted to do. I didn't want to devise lessons, but I just couldn't find the material. I'm
Right.
sure it is out there. We looked at some of the Japanese material, but I didn't, go into it too deeply. But everything I saw there was probably some of the material that I would want to use, but I don't see it elsewhere. So, in terms of teachers, you know, I don't have a great answer. It's why we wrote lessons. What
Yeah.
else can I
Right.
say?
Right. Right. I was just thinking maybe is there the way that you write lessons, sometimes those fundamental practices are sometimes like, if I'm looking at my curriculum resource or my textbook
Yeah.
right now, or I've got a lesson in hand, what are some of those small tweaks that I could be making to my existing resource to bring in rate earlier on? Is it just that, I make sure that I use the context first, and make sure I bring in, like, say it out loud, and keep
Okay.
reinforcing it, the idea of like three packs of gum per group, or three sticks per pack, like just keep saying the rate as much as you can, because we used to do that with like thinking about bringing in models, as kids might not know the appropriate model to draw, but then when you emulate it on the screen, you ask them to describe, and you can call out the attention to the detail, and you can do that over and over again, and kids pick up on that. Is that the type of
Okay.
moves that we make as teachers?
So I'm glad you pushed me a little farther on that because I do know what I want to say because we had talked about this as a research team. What could teachers be doing? And we felt like that the most powerful thing we were doing, we tried different things, was simply labeling what the referents were in any given situation.
Right.
So if you write an equation, what are those things? What do those numbers mean? And really having a handle on that. And you can use any resource, I would
Right.
say, and do that. It's just that the reason I was hesitating is if the resource says, draw 3 empty groups, put 4 in each,
Yeah.
that's hard to change. But if what you have is kids are solving word problems and you're writing out the solution to the problem, then I'm going to focus on, well, what do each of those numbers mean? So we always set it up before. What do we know? What do we not know? What are we looking for? And we're not even talking numbers then. We're just talking, what is it we're actually looking for? Are we looking for the pieces? Are we looking for the amount per pack? And that was the most powerful thing I think that we're doing.
Yeah.
So that you could adapt to anything except for the one situation I talked about.
Right. Yeah, like I'm imagining, like if you're modeling someone's thinking on the board or you're modeling the question, it's like you're not. I think we would typically strip the context when you go to write an equation, you write the numbers,
That's right.
you write the sentence, right? The sentence starter or stem, and I would say what you're recommending, and I think what I would do is to not, strip the context. So if I'm writing 3 pieces, then write like not just write 3 times 4. It's like 3 pieces times 4 per pieces per group. Like write it out and not like eliminate it from the actual board work you're doing or modeling you're doing with, even if you're drawing it, it's like clearly label everything.
And so when you talked earlier about the transition to division, you can also achieve it with that. So if we set up the original equation, what is it we know? What are we looking for? And the empty box, like just using Carpenter's work, the empty box is what we don't know yet. We can even label that so we know what it is. And then they just have to do the often mental calculations. We do a lot of mental work.
Right. Yeah, no, that's great. That's great. Do you think, I guess, like we always talk about, one of the biggest kind of barriers to strengthening students' understanding is making sure the educators we're working with and supporting also understand that. How important is that? Is the exposure and the repeated, like just doing math, do you believe with educators, like the educators themselves probably have to practice this themselves when they're doing multiplication, so that it can be they can be confident in the classroom with students.
Totally, because they haven't learned it this way. I certainly had not learned it this way. I never taught this way. So, it actually took us about a year to come to grips with the fact that this is the way we wanted to approach it. I kept resisting it. And so in terms of the teachers, we actually do a lot of word problem analysis, and then looking at the actual equations and what type of problem is this and what are the referents. And we have games that we play that they can just play with to experiment themselves and think about it. Because we were out in Grand Erie a couple of weeks ago, and one of the teachers said, I really don't like this, missing factor multiplication. Where's the division? I just want to do division. That's how I think about it. So we were laughing about that and had a good discussion around it, because it is a new way to think for some of us, and I'll include myself in that, to think about division really being just all multiplication in a way. It's just, the unknown is somewhere else in that equation. But if that's not your training, like it would be your training, but if that's not your training, it's hard in the beginning to think about it that way. So we spent a lot of time just playing with things, and then we get to look at kids who are always, a better sell than me talking.
Right. So when we're thinking about supporting teachers but who are supporting kids, what are some of the blind spots? Like what are some of the areas that you saw didn't work?
So some of the areas that didn't work in the classroom that we're still worrying about, and I don't know if this is pandemic or I don't know the source of this, but we are still seeing, and the teachers are agreeing when we talk to them about this, we're still seeing a lot of kids coming in grade 3 and 4 trying to learn multiplication, and they are still single counters. So we always have, when we interview kids, we always do an addition item first just to see where they're at. We don't want to, interview them and have them really have an unpleasant time in the interview. So that's where we start. But we have kids still who need to count on for 8+6. We even have kids who still need to do counting 3 times. And it's going to be really hard for them to learn multiplication and to take up those ideas and get in on the discussion if they're still single counting. And I worry that they will fall far enough behind that they just get given a calculator,
Right.
times tables taped to their desk, and that's it for them. That's how I feel.
Right.
And so I worry about those kids. And I think, and the teachers worry about those kids. We definitely had those discussions.
Right. Right. If there was one big idea, you want to leave with the teachers or the coaches or the coordinators listening right now, what would that one big idea, the one takeaway be?
Well, I liked your question before, and really it's about helping kids when they're looking at word problems, when they're looking at those quantities. What is a quantity? What is it we're looking for? And helping them to have that structured way of looking at things so that it's not a mystery for kids what they're trying to do.
Awesome. Alex, you mentioned lessons, you mentioned the book, like if I'm listening right now and I want to dig deeper, where can I go to get more from you, learn from you, get access to that upcoming book, or maybe it's out now. Let us know where we can go.
I don't really have any social media things. This is a complaint on the more technical people in my team. So we have none of that. So aside from the publisher, there is nowhere right now. We promise we're going to try, we being me.
Right.
But I have nothing like that now.
No worries. We'll put the publisher information in the show notes. So if you're looking to learn more from Alex's work, you can scroll down in the post there and click away and find her work. Alex, we want to thank you for joining us here on the Making Math Moments That Matter podcast, and looking forward to many more conversations together.
Thank you, John.
Awesome. Thanks.